So it is given here. See, if the number of forces are acting at the same point, then we call it as concurrent forces. Okay. So when the number of if all the concurrent forces are acting at a point and the system is said to be in equilibrium, then their sum, the resultant sum is 0. When I say the resultant sum, it is the vector sum. So f1 vector plus f2 vector plus so on till fn vector is equal to 0. If there are only 3 concurrent forces, f1 vector plus f2 vector plus f3 vector will be equal to 0, or this f1 by sine alpha is equal to f2 by sine beta is equal to f3 by, it is actually f3 by sine gamma, and this is what is called as Lami's theorem. As I told you yesterday, I will explain this Lami's theorem if they have informed you or taught you in the school. Okay, or else we are going to solve only using free body diagram. Both will generate the same answer. Shall we start? Guys, I need some response. Yes or no?
Yes, sir. Yes, sir.
Okay. So the first problem we have already solved. Right, yesterday we solved this. Next, let us try to solve the second problem. Determine the tensions T1 and T2 in the strings shown below. Okay, so there are how many strings, guys? How many strings are there? There are 3 strings which are connected to the same point P. Right. So this is one diagram and this is another diagram. I think they both are same. Yes, they are. So they both are the same. Okay. This the thing is they have resolved it into components and they have given it answer. So what exactly is happening is the point P is at equilibrium. The equilibrium is maintained due to 3 strings. So 3 strings means how many tensions?
3 tension.
So number of strings will be equal to the number of tensions. So 3 tensions are there, T1, T2, and here there will be T3. Right. Now we need to find T1 and T2 from this diagram. So our work is to find T1 and T2. It is not given in the whole. They have given no, determine the tensions T1 and T2 in the strings. Okay. So how to solve this? Tell me. See, there is a weight given as 4 kilogram weight. Make a note, 1 kilogram weight is 10 Newton, or you can write it as 9.8 Newton. 1 kilogram weight means, so the meaning of 1 kilogram weight is if I have a 1 kilogram block, so kilogram is the unit of mass or weight. Kilogram is a measure of mass or weight.
Mass.
Mass,
It is
sir.
1 kilogram. Kilogram is the measure of mass. So kilogram weight means what is the weight of 1 kilogram mass? So how much weight will it experience? It will experience a force of 1 into 9.8 Newton. That will be 9.8 Newton. If you take the acceleration due to gravity as 10, it will be 10 Newton. That is the meaning. So 4 kilogram weight, we will approximate it to 40 Newton. And here also it is 40 Newton. Is this point clear?
Yes, sir.
Okay. Now we will draw free body diagram. So how many free body diagrams are going to be there? If you take point P, along the horizontal direction, what are all the forces acting on it? See, let us not look at this diagram. If I draw a perpendicular, okay, let's try to resolve. If I drop a perpendicular, then this is going to be 90. How much is this angle?
30.
It is going to be 30, right? If I draw a line like this, this is 30 means how much is this going to be? It will be 60, right? So that is what they have given it as 60, the alternate interior angles, right? Now this T1 is resolved into 2 components. One is T1 cos 60 and T1 sin 60. This part will not be given in the exam. Okay, this part you have to do it. So what is the horizontal force acting on the particle P in the right side direction? What is the
T
force
cos
acting?
60.
T1 cos 60. What is the force acting on the particle P in the leftward direction?
T2.
Yes, that's it. It is T2. So there is one such diagram. Similarly, if I draw a the free body diagram of the 4 kilogram block, 40 Newton is acting downwards. What will be acting in the upward direction to balance it? So the block is connected to whom? The block is connected to which object?
T, sir.
Sorry, I didn't get it. Here, it is connected to whom?
T.
It is connected to string. So string will offer a reaction force, tension. Instead of writing it as T, I will write it as T3 because I'm treating it as a third string. So T3. Similarly, the point P is there, no? This point P at this place. What is the upward force acting just above that?
T1 sin 6.
Yes. And what is the downward force acting just below that?
T3.
Very good. It is T3 because this is the third string and this is also the third string. So a third string has the same tension T3 in opposite direction as it is an action reaction. Now tell me, all the forces are balanced. If I write the relation for this, then what will it be? It will be T1 cos 60 is equal to T2. Similarly here, T1 sin 60 is equal to T3. And T3 from this is equal to 40. Solve and tell me what is the answer. So what I'll tell you the method to solve. Take this T3 and substitute it here. Then you will have T1 sin 60 is root 3 by 2. So T1 into root 3 by 2 is equal to 40. Similarly, once you get T1 substituted here, then you will get T2. Solve and tell me. Make it fast. So you will have 80 by root 3 as T1. So 80 by root 3 means it is 80 root 3 divided by 3. So 80 by 3 is approximately 27. So 27 into 1.7 will give me how much?
Approximately 45.9.
45.5. So that is what is T1, approximately 45.5. Similarly, substitute 41.5 here, 45.5 here. Cos 60 is half. So half of this is 22 point something. That's the answer. Right? So what we did is right. So now I'm going to leave this
doubt.
problem. Yeah, tell me.
We can't leave the answer in groups, sir.
You can.
Okay, sir.
Okay. So a train is moving along a horizontal track. A pendulum suspended from the roof makes an angle of 4 degrees with the vertical. So instead of 4 degrees, let's make it as 30 degrees, okay? 30 degrees with the vertical. Obtain the acceleration of the train. Okay, this question you can leave because there is a concept called as pseudo force to be applied, which is not there in your syllabus, so don't worry about it. This one you can do, fourth you can do. So there is a ball of mass 1 kilogram which hangs in equilibrium from two strings OA and OB. What are the tensions in strings OA and OB? This one you guys can do it. So how to solve? So if you take this point O, okay, if you take this point as O, if this is T1, then how will you resolve it into components? That's more important, right? So if I draw a line like this, means if I draw a line like this, then how much will this angle be?
degree.
That's right. So it will be 30 degrees. So this is also 30. So T1 alone can be resolved into two components. So let's try to resolve each force into different components. T1, how much will this be?
Even cos 30.
That's right. And this one will be T1 sin
30.
theta. Similarly, if I take T2, if I draw a line like this, then T2 is like this. Then how much will this angle be? This is
T2
9.
cos 6.
So this is 60 degrees. This will be T2 cos 60. And this will be T2
Sin 60.
sin 60. Right. Now, what is the only force that is acting in the downward direction? 10 Newton. I told you, 1 kilogram weight is 10 Newton. Is this clear? So what I'm going to say is for object to be in equilibrium, sum of all the forces sum of all the forces in x direction is 0 and sum of all the forces in y direction is 0. So tell me what are all the forces that are acting in x direction. So if I take the reference as x and y, what are all the forces acting in x direction? Look at all the three diagrams. Okay? So in all the three diagrams, what are all the forces acting in the xward direction?
T1 cos 30 and T2 cos 60.
Okay. See, T2 cos 60 minus T1 cos 30, can I write it as 0? Why did I put a minus sign?
Because they are in the opposite direction.
Opposite direction. Similarly, for sigma Fy to be 0, what are all the upward forces? T1 sin 30 plus
30
T2 sin 60 minus
Minus 10 Newton.
Newton.
equal to 0. So how many unknowns are there in the question?
2.
2 unknowns.
So 2 unknowns means you need 2 equations. Solve those 2 equations, you will get the answer. Okay, I'll tell you how to solve. See, I'm telling you all these things because these kind of questions are applied in derivations also. At that time, you should not struggle. Okay, ensure you're clear with all these things. Sorry, just a minute. So T2 cos 60 means T2 by 2 minus root 3 by 2 equal to 0. Similarly, T1 sin 30 means T1 by 2 plus root 3 T2 by 2 is equal to 10. Okay, how to solve, guys? So from this, can I say, if I take the 2 to the other side, can I say T2 minus root 3 T1 is equal to 0? From this, can I say T1 plus root 3 T2 is equal to 20? So what can we do? So treat them like
Can
x and y.
equate.
How will you equate? You cannot know. Treat them like x and y, no? So I want T1 to get eliminated, or I will multiply first equation with root 3 and add to second. So I will have root 3 T2 minus 3 T1 is equal to 0. T1 plus root 3 T2 is equal to 20. If I do this, this and this will get cancelled. Minus 1 minute, wait.
We have to subtract, no, sir.
You can do add, you can add or subtract. Oh, we have to subtract. No, yeah. I thought it was minus. Yeah. Then it will become minus 4 T1 is equal to minus 20. This and this will get cancelled. T1 will be equal to 5 Newton. Is that what the answer is? Yes.
Yes, sir.
T1 is 5 Newton. Once you substitute in any one of the equations, so if you substitute in first equation, T2 is root 3 T1. So T1 is 5, so 5 root 3 Newton is T2. Are you clear? So there are certain important derivations where you need to do all these mathematical part also. So you should get used to this. There you will not have numbers. At least you have numbers here. There everything will be in terms of theta only. I hope this is clear. Okay. So the remaining questions you people have to solve. I will upload it as assignment. And any doubts, I'll clear it in the next class. Okay. Now I'm going to the next part of this chapter, that is friction. So with this, the first part, the Newton's laws, everything is over. Now we are going to deal with friction. We are going to see what is friction, what are the different types of friction, what is the cause of friction, and what are the applications of it. Okay. So write down the heading as friction. So now let's come to this point, come to the definition of what does friction mean. So what does friction mean? You can tell in your own words, man. I'm not expecting book definition. Whatever is your understanding, tell me. Do you know what that word friction is? You have experienced in your life.
Sir, I will tell in a lay, like.
No, that's fine. That's fine. Layman is
Sir,
more than
I
fine.
think so. Friction is like a opposite force law. So like
Okay.
when you walk on a
See.
street, it will always give a
Okay.
like if the
It will
ground.
give an opposite
Yes.
force supporting you to walk. That's what you're
Yes.
trying to say.
Yes.
Right? Okay, that's right. Okay. Okay, I understand what you're trying to say. So that's from your understanding. So let's try to put it in a more polished way. That's it. What you told is right. I'm not denying it. Let's try to put it in a more polished way. Now the question is, so we have experienced something like there is a resistive force while we walk. If you walk on a rough surface, this is what has been observed, right? So you always remember, physics, the terms are not given first and then the theory is introduced. Physics is all about what you observe. If you observe something, you give a name to it. That's it. Okay. So friction means, let's take the example of what you told. When you walk on a rough surface, it is supporting your motion. How is it able to support? By providing friction itself acting as a resistive force, right? So keeping all these factors in mind, can we give a definition to it? So one thing we need to ask is it a resistive or a supportive force?
Sir, your screen is not visible, sir.
Yeah. Is it a resistive or a supportive force?
Resistive, sir.
Okay. So by offering resistance, so if something is offering a resistance, it has to achieve something, right? So what is the main motor of friction? By the friction offering resistance to whatever object is trying to move, what is it able to achieve? That's what the question is. So I'm going to give a definition to it. Observe. It is a force which acts between layers. Are you able to understand? So it is a force which acts between layers where it tries the relative motion. This word is very important. The relative motion of one with respect to other. Okay, so write down this. Force which acts between layers where it tries to oppose, underline this word, the relative motion between, or say relative motion of one layer with respect to other. One means one layer actually. Okay, one layer with respect to other. Let's try to understand what exactly it means. Okay, so shall we visualize what it is? What am I trying to say by these layers and all? Okay. So see, the concept which I'm going to tell you, it's not given in textbook because they will not use the word which I'm going to use. So concentrate. Now I'm going to switch on my video. So just a minute. Let me get few objects. One minute, I'll be back. Guys, observe. So listen. So I have a set of books in my hand. Okay. I have a set of books like this. Now, tell me what is the physics involved behind each book. So I'm trying to hold these books like this. Okay. So what will the first book try to do on the second book? Can you tell
It will
me?
try to exert a force
In which direction?
in the downward direction.
The downward direction, right? And what will the second book try to do to the first book? It will exert a
It will
force
try
in the
to
upward direction, which is called as the, what is the technical name of it? It is called as the normal reaction. Accepted. So the force exerted by the first book on the second book is the weight of the first book. The force exerted by the second book on the first book is
Normal.
the reaction.
normal reaction.
Okay, that is happening in which direction?
The upward force, sir.
No, it's happening in the vertical direction. I'm not talking about upward or downward. It is happening in the y direction. If I take this as x-axis, this as y, I speak only in terms of x. So it is happening in vertical direction. This point you able to visualize, right? Now let's analyze what is happening. Sorry.
The video is breaking, sir.
Okay. Let's see. So if you look at what is happening between the second book and the third book, what is happening? The second book is, so let's forget about second book and third book. Now tell me, on the third book, how many forces are acting?
Two forces, sir.
So it is, if the mass of the first book is m1, mass of the second book is m2, then m1 plus m2 into g is acting in downward direction, and this is offering some other reaction in. I hope you are able to visualize till this point.
Yes,
Now,
sir.
now the question comes. Now my interest is, I want to take the second book from the lot separately. Okay, I'm trying to take the second book from the lot separately. When I try to move this, what exactly is happening? See, what would have been my expectation? So what is my objective? Tell me. My objective
Remove the second book.
is to take only the second book. I'm touching only the second book. I'm not touching the other books. Okay, let's say the second book has come out. It is out till this much point. I am applying a pulling force. I'm trying to pull the book out. But what is happening? Is the second book alone coming along with me?
No, sir.
What is happening?
The
we
first book is
we
The book
expect that the second book will come like smoothly, but in
So
reality,
what we expect, that's right, Shashmit. So when you try to pull this, what we expect is, see, this is what we expect, right? This should come out and this should fall. Means that is what we expect. Means when this comes out, it should be like this. This is what we expect, correct? But that's not happening. Why? It's a very simple activity, right? You're able to observe. You're able to obviously see something in front of your eyes. Right? There is nothing like hidden story. You're able to see you're doing an activity, but this is what you're able to observe. It's if you see the first book is also moving. Now, if I ask you what physics is actually involved behind these books, what will you say? Why is that happening in the first place? Can you guys think of a theory for it? Why is it happening? Why is the second book not coming separately? Why are they moving as one object? So many questions, right? You guess, no? I don't mind. See, it's a discussion. I'm not testing your knowledge. It's just a discussion. You tell me whatever you want.
I think so. I'm telling layman words. I think so. There
Yes.
are many external forces. Not only one force is not just acting on that book, second book, but many
Okay.
other forces which are responsible to make the two books slide together.
That's right. That's absolutely right. I'll give you what are the word which use many external forces. If you ask me to give the answer in one word, I will use the word friction. Okay. Now I need to answer the question, how is friction actually existing between my first book and the second book? I need to give an answer to it. Right? So, shall we try to draw the diagram and see? Let's try to analyze what exactly is happening. Shall we go to that page? Right?
Okay.
See, if you understand this point, it is very simple, guys. It's not a very big concept. Now you need to understand what exactly the relative motion means, because I'm trying to explain this word. So, the third book, second book, and the first book. Where did I apply the force? First, second, and third. I applied the pulling force on the second book. What came to our observation? The second book alone didn't come out. Rather, I was able to observe that the first book also came along with it. Maybe it depends on my force. If I give a jerk, means if I pull it very fast, if I pull this book very fast, maybe this would have fallen down. But I pulled it a little slow. I pulled it on a comparatively slow basis. Accept. Right? I didn't give a jerk. Jerk means pulling it very fast. I didn't do it. I applied a constant force on it. Are you guys able to visualize till this point?
Yes, sir.
Okay. Now what I'm going to say is, I need to analyze what exactly made the first book and the second book to get attached to each other, though I didn't put any glue between them. I didn't apply any adhesive force between them. But what natural phenomenon is actually happening between these books that they are actually being treated as one object? That's what I need to understand. And the answer is, to what Shashmit told, that so many forces are what are called as the intermolecular attractive forces. Means what exactly will happen is, to our eyes it will appear, even if you do a perfect lamination, right, to our eyes it will appear as if it is a completely smooth surface, but every surface in this world will have certain amount of irregularities, right? So this is an irregular surface. The bottom of the first book is going to be irregular. Similar way, the top of the second book will also be irregular, due to which what is happening between them? What is happening between them? They are getting interlocked. Are you able to visualize this, guys? This is a microscopic parameter. This cannot be seen with our normal eyes. You need a microscope to observe this. There is a microscopic property. If you observe it, yes, there will be irregularities for every surface on this planet. It is impossible for you to generate a completely smooth surface. There will be some irregularities, maybe at least on a microscopic level. Are you guys able to understand this? So,
Yes.
what is the reason for friction? If someone asks you, why is friction actually existing? Your answer should be only one word. What is it? It is because of the interlocking of the irregularities present between both the surfaces. See, it is because of this interlocking only. What is happening is, when I apply a force on this, these two are already interlocked with each other. That is why they are able to move as one object. That is the reason what happened. Okay. Now let's try to observe the free body diagram of what exactly is happening. Okay. So let's try to observe using the free body diagram. So this is my first block. This is my second block on which I applied the force. So it is my system. My system was only second book, right? So when I applied the force on the second book, how did the object move? How did the first object actually move? How did the first object move, guys? That whatever you observe, you need not bluff. Whatever you observed, you tell me. When I applied the force, a constant force on the second book, the first book also moved together. In which direction?
Right hand side there.
In the same direction in which I applied the pulling force. Am I right?
Yes, sir.
Now again, I'm revisiting the first law. What Newton told me. So the Newton's first law says an object will move, or it will continue. An object will stay at rest, or it will be in uniform motion, unless and until there is a force applied on whom?
On the object.
On the object, right? Here, the first book is also an object. Did I apply any direct force on the first book externally?
No, sir.
Then how is it moving? Then the Newton's first law should have been invalid, right? but it is not happening. I am able to observe it is able to move. So there is some other force that is existing which I'm not able to observe, which is actually existing between both the objects, right? So observe what exactly is going to happen. This is how friction will actually act, guys. Okay, you need to be very careful. So when you apply this force, the second object will actually try to apply a small force F, which is called as friction, because there is already interlocking existing between whom? Between the first and the second hook. The second object will try to apply a frictional force in which direction?
The opposite direction.
It will be applying in the opposite direction, such that the relative motion between both is stopped. Okay, so this direction it will happen, but this will not be able to succeed because friction is similar to tension, where it is not similar in terms of pulling. Tension is always a pulling force. Here, friction is a resistive force. That's what we are saying, right? So I told you one more important point with respect to tension. What is that? If you consider the string to be massless and inextensible, the tension acts in both the directions at each end. I called it as, what is the name I gave? Action.
Action reaction.
It is an action-reaction pair. Means on one object, if it acts in the rightward direction, on the other object which is in contact with it, it will act in the opposite direction. So what exactly is happening is the same thing. See, means the second. So this is what is happening. But what is happening is the first book is actually experiencing a force in this direction of the same value F, and this is the only unbalanced force which is responsible for the first book also to move, though you wouldn't apply any direct force on it. And what is this force? It is the same friction. Means what I'm trying to say is, if friction on one object is acting to the right, on the other object which is in contact with it, it will act in the leftward direction. So that is why if you observe, friction is also an action-reaction pair. Okay. I'll tell you what would have happened is, in your lower grades, you would have learned something like this. When you have a block on a surface, let's say the surface has friction associated with it. If you apply a pulling force, then they would have told you that there is a frictional force acting like this. This is what you have learned.
Yes.
Am I right? This is what you have learned. But none of you told what exactly is happening to the floor. Did you ever ask that question? Okay, floor is applying a force. You are applying a force on the block, and they would have told you that the floor is trying to oppose the force that you try to apply. So when friction is existing, friction is a relative quantity. Means if the first object is exerting on the second will also exert on the first. Okay. So if I try to draw the free body diagram of this block, when you apply a capital force, when you apply a force capital F in the rightward direction, yes, there will be a small frictional force that will come into picture. My question is not about whether it is more high or anything of that sort, but there is a resistive force acting if I use the word rough surface. But if you try to draw the free body diagram of the floor, then there will be a frictional force acting in the rightward direction on whom? On the floor also, and this frictional force is offered by whom? So here you have two objects, guys, block and floor. Now, this force F is offered by whom?
The floor.
This is offered by the floor on the block. But what will the block try to do? The block will not be just taking, it will also try to react. Okay, the block will also try to oppose. So block will try to exert a force of the same value F on whom? So this F is applied by the block on floor. Okay, but what will ultimately happen? The force exerted by the block on the floor is not sufficient enough to move this floor. That is why we never speak about it, but this happens. So what is the important point to be noted here? What is a very important point that you need to note here? that friction is an action-reaction pair. Means if on one object is acting to the left, on the other object it will act to the right, where it is trying to oppose the relative motion between both the layers. Means if one, yeah.
Friction is an action force. Then why can't we bring in Newton's third law, sir? Then we can say that friction will be equal to the force acting on the object, no, sir?
Then object should not move, no? If you are able to see that the block is moving, then
Sir,
capital F will be equal to small f, no?
Sir,
Huh?
sir, if the object is moving means then the friction will also increase, the force will also increase, no, sir? Then we can say that according to Newton's third law.
Wait. You don't know much more about friction. I just told you that this is the way it acts. Depending on how it acts, the friction is again classified into different types. That's what you need to understand. After I teach that concept, you ask the same question, you will get clarity. Okay, as of now, I'm trying to tell only one important point, that friction is an action-reaction pair. This point should be in your mind. Though in the exam part of you need not draw all these things, but this is the actual physics that is happening behind friction. Okay?
Okay, sir.
Sir,
Yeah, tell me.
I have a doubt in that book question, sir.
Yeah, tell me.
The friction exerted by 1 and by 2 are equal, no, sir, in magnitude.
Yes, they are equal.
Then, sir, both are in opposite direction, no, sir.
Yes.
So they would cancel each other out.
They will cancel, yeah, obviously.
Then why would one move, sir, at all? It would just be stationary, no, sir.
It is station. See, if you're standing here and observing the book, okay, like I was holding and you were seeing the book, right?
Yes, sir.
That time it appeared as if this book was moving. Accepted?
Yes, sir.
We saw that the book was moving. Whereas if you stand here and observe the same book, what would have happened?
It would look stationary.
It will look stationary because you're also moving. Because here, what is the word I'm using? Relative motion. That is why here you need to bring in the concept of frames of reference, which I don't want to bring and confuse. Okay. So here, one thing, when you're drawing the free body diagram, next time onwards, when you draw like this, you should not get confused.
Okay.
Sir,
Okay.
if I'm right, the frictional force will act differently with the different states, no, sir?
Different with different.
Different states, like solid, it will
Yes,
act
it will be. Yes, it
with liquid, with gas.
Yes, it will be. So the friction that is existing between solid and liquid is called as viscous force. I'm not sure if you have heard this word. It's called viscous force. Similarly, the force acting between a solid and a gas is called as, mostly gas in the sense I'm talking about air, is called as air resistance, or we call it as a drag. Everything is a frictional force only. Okay. So here we are trying to talk about the friction that is existing between two solids. Okay. Now I'm going to explain one important point. Okay, I'm going to bring in one mathematical expression based on the observation. So if suppose I have a block which is lying on a surface of mass m, okay, then what are the vertical forces acting on it? mg and n, capital F. Okay, let's say the floor is rough. If I take small f to be the resistive force that is acting on the object. Okay, going forward, I'll draw like this only, but you should have it in your mind that the block is also trying to exert a force on the floor. That point, I will not draw it every time. So I'll be drawing it this way only. So one important point to be noted here is that the frictional force is directly proportional to the normal. Okay. So in this case, n is equal to mg. Correct? So in this case, n is equal to mg because vertically it is balanced. The object is moving only along horizontal direction. Vertically, it has no acceleration. Right. So the frictional force is directly proportional to whom? The normal force, which implies F is equal to what? Mu into n, where this mu is called as coefficient of friction. Okay. So F is equal to mu into n. You can either treat it like a formula or it is a concept. So while we solve the problems, we will be applying this as the force. force, the frictional force, value of frictional force. This is defined as mu into n. Am I clear till this point? This mu is called as the coefficient of friction. Okay. So one important question that is raised by many people is, I wrote friction is directly proportional to normal. In this case, normal is equal to mg. Why didn't I say friction is directly proportional to the weight of the object? I could have told, right? I'm only using friction is directly proportional to normal, but I never use the word friction is directly proportional to the weight of the object. Why?
Sir, because weight is the inner force of the object.
Okay. Then what about normal?
Angles will be.
Sorry, I didn't get you. Why are we not using weight? It is because, see, logically things
Because it has no relation with
no relation with.
uh, the surface.
You're almost there. Can you refine and tell your statement? You're almost there.
Sir, friction is proportional to the force with which the object pushed against the surface, sir. So the normal force is not equal to the force due to gravity, sir. Like, it's not always equal to the force due to gravity, sir.
Okay.
So therefore, the force.
Can you give me an example where normal is not equal to weight?
Sir, normal is not.
Where normal is not equal to mg. Can you tell me one scenario like that? Very simple. When the object is lying on an inclined plane.
Sir, something like elevator, sir. That elevator. Sir. Elevator, sir.
Because elevator I have not explained. So from the concept which I have already explained, in this case, normal is not equal to mg, it is equal to mg cos theta. And more importantly,
Sir, weight is negative, sir.
which is negative.
Weight. Since it is, sir, since it acts in that, it's a negative.
What is it?
So you can
It is not, I don't have any, it has nothing to do with negative or positive. Okay. I'm just trying to equate them. So n is equal to mg cos theta when the object is lying on inclined plane. So here, why I didn't write mg is because weight is the property of whom? So how many objects are there in the system?
Two objects, sir.
What are the two objects? One is
The block and the floor.
floor. So when you say rough surface, are you talking about the block or the floor? Who's offering the friction?
The floor surface.
So here, whatever friction I've written on the block, this friction is offered by the floor, right? So if I give you two parameters in hand, normal and weight, which is the other property that the floor has? Is it the normal or the weight of the object?
Normal.
Weight of the object is a property of the object, whereas normal is a property of the force. So, property of the floor. So friction is also a property of the floor. Normal is also a property of the floor. You can relate two quantities only if it is a property of that particular object. That is the main reason. Is it clear? So friction is directly proportional to normal. It is not proportional to mg, because I've seen this mistake. That is why I'm stressing on this point. Many of them, they start writing it as mu mg, just because they are comfortable with it. No. You should always write friction is equal to mu into n. And then only you need to find for that particular case, what is the value of n in terms of weight of the object. If the object is lying on the floor, yes, n is equal to mg accepted. Whereas if the same object is lying on an inclined plane, n is no more equal to mg, rather it is equal to mg cos theta. Are you able to understand? So this is a very, very, very important point, where mu is called as the coefficient of friction. And how can you write mu as? Mu is equal to f divided by n, and it is a dimensionless quantity, means it doesn't have any units also. Are you guys clear with this? Right? So mu is equal to F into N. So I need an answer to confirm. Answer for confirmation.
So F is
Done?
friction.
Sorry?
F is friction, no sir. Mu is equal to F by N.
Mu is equal to F by N. That's it. So it's a
F-
dimension.
F
So
is,
friction is also. The voice is breaking.
so F is friction, no sir.
F is yes. F is friction. N is normal. So for friction, the force, the symbol which is used is small f. Okay. So one last point that I'm going to explain for today is called as static friction. Okay. So it's called as static friction. The meaning of this is, see, let's try to analyze a scenario. Let's say I have a block of mass 1 kilogram. Okay. Let's say I have a block of mass 1 kilogram. Then tell me what will be the, I kept it on a floor. Then what will be the weight acting on the object? The weight of the object will be 10 Newton. And the normal force in this case is also 10 Newton only, because in the vertical direction, it is in equilibrium. Let's say this floor has a coefficient of friction 0.5. I'm just giving you some number. It has a friction of coefficient of friction as 0.5. Now I am applying a force of 1 Newton. Okay. Now I am applying a force of 1 Newton. I have already given you a formula. F is what? What is the frictional force that is going to act on this object? So frictional force offered by the surface in this case is mu into N. Mu is how much? 0.5 into N is how much?
10.
It is 10. So it is going to be 5 Newton. So 5 Newton is what? 5 Newton is the frictional force offered by the surface to the block. Now tell me, how much is the horizontal force, or how much is the effort I am trying to apply on this block? I am applying a force of 1 Newton, but how much is the force the floor is able to offer me?
5 minutes.
5 Newton. Now tell me, will the block be able to move?
No, sir.
No, because I didn't succeed in moving it. Now I am increasing it to 2 Newton. I am again going to fail. Again 3 Newton, fail. 4 Newton, fail. 5 Newton, still fail. 5.00001 Newton.
More little.
It will move a little. Yes, I will succeed in moving the object. Means I will be able to overcome the friction. That's what I'm trying to say. Correct? No. So that is what is going to happen, because I know how much is the frictional force offered by that particular surface. I have information about it. Now the question is, when I apply 1 Newton force, what is the value of the frictional force that is going to come to stop me from moving the object? So what is the frictional force the surface can offer? 5 Newton. But the question is, does the frictional force need to use all the 5 Newton which it has to stop me, or it can use only 1 Newton and stop me? I'm repeating the question. I have applied 1 Newton force. I know that the floor can offer me 5 Newton force. During the scenario, when I applied 1 Newton force, how much frictional force should the force exert on the block to stop it?
Meeting more than 1 Newton.
It has to, see, anything more than 1 or exactly 1 is also sufficient, right? When it is 1 Newton, the forces are balanced. Right? The rightward force and the leftward force will be balanced. Means what I'm trying to say is, though the floor is able to offer 5 Newton, when you apply a lesser force, it will not try to bring in all the 5 Newton in picture. Rather, it will only try to apply the force which is sufficient enough to stop the external force. Similarly, when I increase the force to 2 Newton, how much will be the force exerted by the floor on the block? So will it utilize?
Either 2 Newton or more than 2 Newton.
It is only 2 Newton. It will only bring 2 Newton. That's what is going to happen. Okay, it will only be 2 Newton. Similarly, when I increase to 3 Newton,
It will be 3 Newton.
3 will come. 4, 4, 5, 5. 5.00001.
It will still exert only 5 Newton.
It will still be only 5 because it cannot offer more than that. Accepted. Are you guys able to visualize what I'm trying to say? So, till I apply that 5.0001 Newton, is the object moving or at rest?
It's at rest.
It is at rest. So, yesterday I told you, no, static means rest. So, static friction means what? The frictional force that comes into play when the object is not moving. The frictional force that comes into play.
And there also we have to like specify, like in a macroscopic level it is at rest, but in microscopic level we can feel.
No, you cannot feel. You cannot see. You will definitely not have. This can be done as an activity. See, you can take a small block, a wooden block, connect it to a spring balance, try to apply a pulling force and see. You increase it from 1 Newton, 2 Newton, 3 Newton. After a certain point, it will start moving. Then you can calculate what is the frictional force that is coming. You can calculate the maximum value. Here it has nothing to do with microscopic or macroscopic. Microscopic is only for interlocking of the irregularities. That is the only place where the microscopic properties come. Everything else you can see. You can see this with your eyes. Okay. So, when you apply 1 Newton, it's applied only 1 Newton. So, 2. To do what? To keep the object at rest. That is why this friction is called as static friction. So, write down the definition for it. The frictional force that comes into play, when the object is at what?
At rest.
The object is at rest. Okay. And there are certain important points with respect to the static friction. Okay, write it down. It is a self-adjusting force. It is a self-adjusting force. I'll explain what is the meaning of it. So, why we are calling it as self-adjusting force is because till I apply the maximum value of friction that I need to overcome to move the block, it is able to adjust itself according to the external force. Because I told you, when I applied 1 Newton, what happened? There was a force of how much value?
1 Newton.
It was 1 Newton. It adjusted itself. When I took it to 2 Newton, it was 2 Newton only. 3, 3, 4, 4, 5, 5. It was able to adjust till the maximum value it was able to offer me. So the maximum value in the sense, the maximum value till where it can stop the block from moving. That is why it is called as static friction. So that's why it is also called as self-adjusting force. Are you guys clear with this? And one more important point here is this 5 Newton is there, right? This 5 Newton is the maximum static friction the object can the floor can offer to stop the object from moving. So the maximum static friction floor can offer. See, here I'm using the word floor. You can say any object. Floor can offer to stop the object from moving is called limiting friction. So limiting friction is another term which is under static friction itself. So what is limiting friction? To put it in very simple terms, it is the maximum static friction. So limiting friction is nothing but maximum static friction. It is represented by the symbol FL. So if you put F and a subscript L like this, then it is called as limiting friction. Similarly, if you put F like this and an S at the bottom, it is called as static friction. Okay. Now, one important question to be answered is static friction self-adjusting or limiting friction self-adjusting?
Static.
It is a
Static,
static
sir.
friction which is self-adjusting, because limiting friction is only one value. It cannot adjust because limiting friction is the maximum value. It is a single variable. Okay. So the mathematical relation that we can give is limiting friction is greater than or equal to the static friction. This is the mathematical relation to be noted, and this is the last point for today's topic. So limiting friction is greater than or equal to static friction. Maximum 2 more classes will be done, okay, including the problems I'm saying. So with the hope that you understood, is everyone clear? Yeah,
Yes,
tell me.
sir.
Okay. So then we can wind up. Remember, I will give you an assignment from equilibrium of forces. You have to complete it. Okay. I'll upload it in the app and you have to complete it.
For tomorrow, sir.
Not tomorrow, by Monday. By
Okay,
by
sir.
Sunday you have to complete it. Okay. Okay then. You can wind up.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir,
Yeah, tell me.
Thank you, sir.
I'm not able to open the Epsilon app. I told you that day.
Yeah. I have to change your number, right? I'll do that.
Yes, sir. Thank you, sir.